So we're doing polynomial inequalities, okay? So we're going to solve inequalities algebraically. Here's some quick notes. So all we're doing here is first finding the zeros like we've been doing, okay? And then, just like we did with quadratics, you're going to draw one of these lines. So like if our zeros were -1 and 1, we're going to draw lines, and then we're just going to plug in test points. So you'll plug in a test point here, here, and here, and then you're just shading in the appropriate region, okay? We've done this before with quadratics. The only new thing that we're doing today is now we're doing it with polynomials. So cubics and quartics and things of that nature. All right, so this is an example of an algebra of a quadratic. So this is exactly what we were doing before, okay? So the first thing you want to do is just set it equal to 0, or get it equal to 0. So x squared minus 9x plus 14 is greater than 0. All right, and then we want to solve for our zeros. So you do that using the ACB method that we all love so much. So AC is 14, B is -9. So what would your two values be? -7, -2. Good. So you get x minus 7, x minus 2. All right. So then your zeros would be 7 and 2, correct? All right. So those are your two zeros, and that's what you're going to plug in, or that's what you're going to use as a basis for your test point. So I have 2, 7, and open circles. Very good, because it's greater than, not greater than or equal to. All right. All right, so now I am going to do something a little different than we were doing before. It's kind of like a shortcut. So rather than plugging in my test points, so let's choose, we have 0, maybe 3, and 8, okay? Because today when we're doing polynomials, you're not going to be able to just plug in the inside, and if it's not there, plug in the outside, because that won't always work. Okay, so I'm going to, rather than actually plugging this in and finding the value, I'm just going to look at the signs and say whether it's positive or negative. Because a positive number is going to be greater than 0, right? And a negative number is going to be less than 0. So I'll show you what I mean. So with 0, okay? 0 minus 7, is that negative or positive? Negative. 0 minus 2, is that negative or positive? What's a negative times a negative? So is a positive value greater than 0? Yes. So now I can shade in here. Okay, see how that's kind of a quick way to do it? No? Alright, that's fine. So you'll do the same thing with 3. 3 minus 7 is negative. 3 minus 2, positive. A negative times a positive is a negative, and a negative value is not greater than 0. Any negative number is less than 0. So we do not shade that in. So I don't shade in between 2 and 7. So the last thing I have to plug in is 8. So if you plug in 8 here, 8 minus 7 is a positive. 8 minus 2 is a positive. Positive times a positive is a positive. Positive value is greater than 0, so I shade in to the right. For your final answer, you can't just leave this. You have to write out the intervals. So you'd say, okay, x is less than 2, and x is greater than 7. When it's going in two separate directions like this, you cannot write x 7 is greater than x is less than 2. That doesn't really work. That's not a correct interval. So you have to write it as two separate intervals. You can only write it as one when it's in between. All right, so here you see now we have a cubic. And this is pretty nice because it's already in factored form. So you don't even have to factor it. So your zeros would just be d equals -1, 4, and -2. All right? It's already in factored form, so you just set each of those equal to 0, and you get -1, 4, and -2. So again, you're going to draw your line. I have -2, -1, and 4. And this is less than or equal to 0, so now I'm going to have closed circles. All right? Algebraically. So again, I need to find test points. So you see now, this is when it's going to be much faster to just look at the signs, because we're going to have to plug in, 4 test points. So I could have -3, -1.5, 0, and 5. So -3, -1.5, 0, and 5. And here, when is the statement going to be true? When we get a negative or a positive? A negative, right, because it's less than or equal to 0. So -3. I get -3 plus 1 is negative. 4 minus -3 is positive. Whoops, I don't need a 1 there. Negative, positive, and -3 plus 2 is a negative. So negative, positive, negative is a positive. So I don't shade in, because negative times a negative is a negative. I mean a positive. Yeah. So then I do the same thing with -1.5. So -1.5 plus 1 is going to be a negative. 4 minus -1.5 is going to be a positive. And -1.5 plus 2 is going to be a positive. So we end up with a negative here. So is a negative value less than or equal to 0? Yes, so I can shade in here. So next we would do 0. So 0 plus 1 is a positive. 4 minus 0 is a positive. And 0 plus 2 is a positive, so this is positive. So am I going to shade that area in? No, because positive value is not less than or equal to 0. And finally, I do 5. So 5 plus 1 is a positive. 4 minus 5 is a negative. And 5 plus 2 is a positive 7. That gets you a negative. So this would be part of your solution over here. All right, if this doesn't work for you, you can plug in all these numbers and get a number value. And you'd get the same thing. Once you're here, you would just write out your final answer. So it would be -2 is less than or equal to D, is less than or equal to -1, and D is greater than or equal to 4. And that would be your final answer. All right, so that's all we're going to talk about with this for today. We'll do a little more tomorrow. But now we're going to jump to today's lesson, which is analyzing the graphs of polynomial functions. So it's exactly what it sounds like. We're going to look at a function, look at its zeros, max, mins, and intervals of increasing and decreasing. All right? All right, so all of these vocab words mean the same thing. If you know this, you don't have to write it down, okay? If you want to write it down, go ahead. But a 0 we know is a 0. That's when it crosses the x-axis. Same thing as the x-intercept. A factor is just the factor. After we factor an equation, we set each factor equal to 0, and we get our 0, which is our x-intercept. And any solution k that gives you a y value of 0 is a 0. It's an x-intercept. Okay? These are all the same thing. All right, so if you're asked for the zeros, the solutions, or the x-intercepts, you're just giving your zeros. And if you're asked for the factors, you just put it in x minus k form. And you've seen that before. Okay? So a 0 is just where it crosses the x-intercept. So those would be your zeros in that graph. All right. So turning points. A turning point of a polynomial is exactly what you think it would be. It's where it turns, okay? So this would be a turning point, and this would be a turning point. When we talk about turning points, we refer to it either as a local max or a local min, or an absolute max or an absolute min. So let me actually continue this drawing a little bit. Okay, so here I have 3 turning points. All right? An absolute maximum means it's the highest point that that graph is ever going to get. All right, so this would have an absolute maximum here. That would be an absolute max. Okay? Because it's higher than everything else on the graph. It's absolute. Whereas this here is a maximum relative to what's around it, right? But it's not the absolute maximum because it's not the highest point on the graph. So we call that a local max. All right? So relative to what's around it, it's the highest, but it's not the highest. All right, what do you think this is going to be here, local or absolute? Why local? Right, because it goes down forever. So even though it's the lowest point that I see here, these arrows tell me that this graph is going infinitely down. So this here would just be a local minimum. Okay? All right, the last thing we're going to look at with these graphs for today is increasing and decreasing intervals. Okay? So here we're looking left to right. So we're going to look at a graph from left to right in reference to our turning points. So you would say, and this is when we talk about increasing, decreasing intervals, we use x coordinates to describe them. So we'd say, okay, from negative infinity to, we'll say, maybe this is -1, it's increasing, okay? Because from left to right, that's going up. From -1 to 1, it's decreasing. And then from 1 to infinity, it's increasing again. So we go from our negative infinity to your turning point to turning point as many times as you have to, and then turning point to infinity. All right, so let's look at an example of one of these. So graph the function f of x equals 1/4 x plus 2 x minus 1 squared. You're given the graph here. All right, your zeros, your x-intercepts, are where it crosses the x-axis. So if you're given the graph, you can just look and see. It's x equals -2 and 1. Okay? If you were not given the graph here, you could easily find them by setting this equal to 0 and solving. All right? End behavior, remember we talk about as x goes to negative infinity, and as x goes to infinity, what is f of x doing? So as x goes to negative infinity, where is this going? Negative infinity. And as x goes to infinity, where is that going? Positive infinity. Very good. Local maximum, local minimum. Where's my local max? At x equals -1, right. Where is my local min? Not 0. Right, at 1. So right here is my min. Okay, so now I need to talk about my increasing, decreasing intervals. So I want to start with negative infinity. So from negative infinity to my first turning point, right here, what is it, increasing or decreasing? Right, because from left to right, it's going up. So I'd say from negative infinity to -1, it's increasing. Okay? So now I want to talk about what's happening from turning point to turning point. So from -1 to 1, is it increasing or decreasing? Decreasing, right. So -1 to 1 I'd put here. And remember, I'm doing this with my x values. And then finally, from 1 to infinity, is it increasing or decreasing? Very good. So from 1 to infinity, it's increasing. So I'd put a little u here for union to say that they're both included. And then I'd say 1 to infinity. All right? All right, this is the last problem we're going to look at today. So it is a word problem, maximizing volume word problem. All right, you're designing a rain gutter. And you're making it from a piece of sheet metal. So just a piece of metal like this. That's 1 feet by 5 feet. 1 foot by 5 feet. And what you're going to do is fold up the edges here and here to make it look like this. Okay, can everyone picture that? All right, so you're turning up the edges. So we can call this distance here x. Okay, so that's my variable so far. How much because the question asks how much should you turn up? Ha ha ha. Okay? The responsible amount to turn up. All right? So what would this here be? If this is x and this is x, what would this be? Remember, this entire distance is 1. Right, 1 minus 2x. Good. 1 minus 2x. So now I've set up all my dimensions. So I'm talking about volume here. Remember, volume is length times width times height. So what would my volume for this gutter be? X times what? Times 5 times 1 minus 2x. Good. Okay, so you multiply this out, and you get v equals 5x times 1 minus 2x. So you'd get negative 10x squared plus 5x. What kind of function is that? So this is a quadratic. Quadratics make parabolas. Is this parabola going to open up or down? Down, because it has a negative leading coefficient. So it's going to look like this. Okay? Where would my maximum be here? The turning point. And what did we call that back like 2 months ago? The vertex, right. So my maximum here is going to be at my vertex. And how can I find my vertex if this is in standard form? Does anyone remember that? You could put it in vertex form, but how could you find the x-coordinate of your vertex? So you do negative b over 2a, and that's going to give you the x-coordinate of your vertex. So negative b would be negative 5 over 2a would be 2 times negative 10. So that's going to be negative 5 over negative 20, which is 1/4. So you should turn up 1/4. Okay? So that's how much you're turning up on each side. So that answers the first question. 1/4 foot. So that would be what? 3 inches? And how do you think you could find the maximum volume? So to find the maximum volume, you just find the y value. So you just plug 1/4 back in here. So V equals negative 10, 1/4 squared plus 5 times 1/4, and you end up getting 5/8 feet squared.